In this video, we're talking about train, validation, and test datasets in machine learning. In machine learning, our goal is usually to generalize, to create a, for example, classification model, classification method, which performs well on never seen before data. The problem is that often you can train a model which performs perfectly, provides very good approximation for the data which was used for the training, but the obtained model parameters can become totally unfit, totally useless to approximate another set of data of the same kind. This is like an effect of overfitting, about which we often talked in our previous videos. For example, here is example of polynomial approximation. The red points are used for training, and you can achieve, for example, with sufficient order of polynomial, even zero error on training data, but we have an unexpectedly large area for test data, blue points. So this is not good. This is called overfitting. So what is the solution? The solution is to split the available data into three subsets: training data themselves, validation data to evaluate the model and tune its hyperparameters, and test data on which we perform final testing. These data shouldn't be used neither for validation nor for the training. So three subsets of data: training, validation, and test set. And here is the question. The question is, why not using just two sets of data? Why should we use validation set? We can go in much simpler way, just using training set and test set. It will be much simpler. So what do you think? What is the reason to use validation set? Well, the reason is that the developing a model involves also tuning its configuration, not just the values of parameters, but principal configuration of the model, so-called hyperparameters. What are the hyperparameters? What is the difference between parameters and hyperparameters? I will give a few examples. The first one is we have a simple multiple regression model. Coefficients W and B are the parameters of this model, but the number of weight coefficients W is a hyperparameter. It defines the configuration of this model. So the order is hyperparameter, but the specific values of W and B, these are the values of parameters. They are parameters. Or for example, hyperparameter of the neural network obviously is the number of hidden layers, or the number of units or neurons in specific layers, which constitute the neural network. Or for example, learning rate for gradient descent is a principal hyperparameter for many machine learning methods. Another example, regularization parameter, which we, by the way, used to overcome an overfitting effect, is also hyperparameter. Yes, so we have tuned all of this. Or final example of hyperparameter is a depth of decision tree. For example, a shallow tree on the left can learn only very basic relationships between inputs and outputs. Its training is simple and fast, but in principle, it's good enough for most applications. But a deeper tree may learn much more complex relationships and tackle with the harder problems. But its training takes longer. Its training is more difficult and can result in overfitting. So this is the difference between parameters, specific values, and hyperparameters, which define the principal configuration of the model. So to briefly summarize what we talked before, the validation set allows to fine-tune, or we also say tweak, hyperparameters. By comparing model performance on the validation set, you can select the best hyperparameters. In this way, the model that performs the best on the validation set is usually chosen as the final model. By using a validation set also, we gain a level of confidence that our model will perform well on the real-world data. So we justified why should we use validation set. So how it looks in practice, this approximate diagram. So we train the model on the training set. We evaluate model on the validation set. And we also can tweak the model to tune its hyperparameters, about which we talked before, on the validation set, and again train the model. Yes, and in this way we should proceed to some time, up to which point we must proceed. We will talk at the end of this video. So finally, we should pick the model that does best on the validation set, and then we should only confirm the results on the test set. And here another question comes. If we already have a validation set, why do we need another test set? Because we get, by testing on validation set, we have some confidence about how our model will perform on the real world data, on never seen before data. Well, yes and no. Because, yes, I should ask you here a question. Why? What do you think? Ask you the same question. Why do we need the test set if we already have validation set? Well, there is a effect of information leakage, because when we tune the hyperparameters of our model on the validation set, in fact, this validation data, they leak into our training data. And the result of testing is not absolutely independent on this data. Yes, in fact, this validation set, in some sense, not maybe completely, but in some sense, in some percentage, it also takes part in the training of the model. That is why we need also test set, which is completely independent, which did not took any part in the process of training, neither in training set nor in validation set. I hope this persuades you. Why do we need it? So yes, to summarize, that is why we need a test set, a collection of examples that is not a part of training set, and it does not participate in the model tuning, which we validation. This third set does not leak any information into your models, so you can safely use it to get an idea of how well the model will perform in future on never seen before data. So we need all three of them. I also want to mention some practical issues with validation set. So of course, it's important to define for ourselves the size of validation set. Of course, there should be some compromise. It should be large enough to provide statistically significant evaluation. At the same time, it shouldn't be so large that we lose valuable training data. And the usual practices are to allot, for example, from 60 to 80% data for training, and the remaining data split for validation and testing, as is shown on these three diagrams as an example. Of course, in your personal application, you may use your own experience, but the basic choice is something like this. Also, sometimes we do not have enough data to perform proper training and validation. Nothing to split. We have a very few data. In this case, a very nice technique, which is called k-fold cross-validation, is used. We split our data, for example, here in ratio 1:4 for training and validation, but we do it several times, in several different times, and then we average our results. Yes, we train the model, we perform validation, but then we somehow shuffle or reorganize our data. New data are used for not exactly the same for training, not exactly the same for validation. And then at the final stage, we average our validation results. So this so-called k-fold cross-validation is often used. What I wanted to mention is that the development set or dev set, just simply dev set, is another name for validation set, and you will find it very often in literature, specifically the dev set. When should we stop the validation or evaluation process? For example, we have some model which we train with the help of gradient descent method. For example, with iterative, iteration by iteration, we refine the values of our parameters. Well, we can lawfully expect that the performance of training set will always, which is not also the case, will always become better and better with each iteration. And the performance development set will also become better, but at the same time it will grow. The error will grow, so some effect of saturation. Then the overfitting, already effect of overfitting is prominent. So we must pick up the point. We must pick up the values of parameters where the training set error and dev set error are the best. Yes, and we should select these values of parameters. For example, parameters W and B for multiple linear regression, an example which we gave today. So in this video, we talked about how it's important to split our data for training set, on training set, on validation set, or dev set for the model evaluation, for tuning its hyperparameters, for tuning its configuration, and also independent test set, which is for final evaluation of performance of a trained model. Thank you very much for your kind attention.